Linear regression is a powerful tool for understanding relationships in data. It's like a magic lens that helps us see how one thing changes with another. Imagine you're selling ice cream. On hot days, you sell more. On cold days, you sell less. Linear regression can help you predict how much ice cream to stock based on the temperature. Think of your height and shoe size. Taller people often have larger feet. Linear regression can help us draw a line that shows this relationship. This line can even help us predict the shoe size of someone if we know their height. Linear regression is used everywhere. Businesses use it to predict sales. Doctors use it to understand the relationship between lifestyle and health. Scientists use it to analyze experiments. It is a fundamental tool in many fields. Let's dive deeper into how linear regression works its magic. We'll learn about the equation and the key concepts that make it tick. Get ready to unlock the power of prediction. The magic of linear regression lies in its simplicity. It uses a straightforward equation to represent the relationship between two variables. This equation is y equals mx plus c plus error. Don't let the symbols scare you. Let's break it down. Think back to our ice cream example. In this equation, y is what we want to predict, the number of ice creams sold. X is the temperature, the factor influencing our sales. M represents the slope of the line. It tells us how much y changes for every unit change in x. The c is like our starting point, the number of ice creams we'd sell on a day with 0 degrees temperature. Lastly, we have the error term. This acknowledges that our predictions won't be perfect. There will always be other factors we can't capture in our simple model. Understanding this equation is key to grasping linear regression. It's the foundation for building our predictive model. Don't worry if it seems a bit abstract now. We'll see it in action soon with a practical example. In the next section, we'll explore the diverse applications of linear regression across various domains. Get ready to see how this simple yet powerful tool is used to solve real-world problems. Linear regression is like a Swiss Army knife, useful in so many situations. Let's explore some of its real-world applications. In the world of finance, it helps predict stock prices based on historical trends. It assists businesses in forecasting sales based on advertising spending. Marketers use it to understand the relationship between promotions and customer response. In healthcare, linear regression helps doctors estimate a patient's blood pressure based on their age and weight. It can even aid in predicting the effectiveness of new treatments based on clinical trial data. Scientists use it to analyze experimental results and understand the impact of different variables. Engineers use it to model the behavior of systems and predict their performance under various conditions. From predicting traffic patterns to understanding customer behavior, linear regression is everywhere. Its versatility and ease of use make it a go-to tool for anyone looking to understand relationships in data. Now that we've seen its power, let's get our hands dirty with some Python code. In the next section, we'll introduce the essential Python libraries for working with linear regression. Get ready to turn theory into practice. Python makes working with linear regression a breeze thanks to its fantastic libraries. These libraries are like pre-built toolboxes packed with functions to make our lives easier. Let's meet our heroes. First up, we have NumPy. Think of NumPy as our mathematical powerhouse. It lets us efficiently handle large data sets and perform complex calculations with ease. Next, we have Pandas. Pandas is like our data organizer. It helps us load, clean, and manipulate our data, making it ready for analysis. Finally, the star of the show, scikit-learn. This library provides us with all the tools we need for building and training our linear regression model. It's like our machine learning workshop. To use these libraries, we need to import them into our Python script. We do this using the import statement. Think of it as inviting these powerful tools to join our coding party. Now that we have our tools ready, let's get some data. In the next section, we'll learn how to load a sample dataset and prepare it for linear regression. Get ready for some hands-on data exploration. Section 5, Loading and Exploring Our Dataset. Let's get our hands dirty with some real data. For this example, we'll use a classic dataset called the Boston Housing Dataset. This dataset contains information about housing prices in Boston, along with various features like crime rate, number of rooms, and more. First, we need to load our dataset. Luckily, scikit-learn comes with several built-in datasets, including the Boston housing one. We can load it using the following code: Python from sklearn.datasets import load underscore Boston, Boston equals sign load underscore Boston. Now our data is stored in the Boston variable, but it's not very useful in its current form. We need to convert it into a format pandas can understand, a data frame. Python import pandas as pddf equals sign pd.dataframe boston.data comma columns equals sign boston.feature underscore names df medv equals sign boston.target. Voila. We now have our data neatly organized in a data frame. We can easily view the first few rows using. We can also get a summary of our data using. Before we jump into building our model, it's crucial to understand our data. We need to know what each column represents, look for missing values, and identify potential relationships between variables. This exploration will guide us in building a meaningful and accurate model. In the next section, we'll split our data into training and testing sets, a crucial step in building a robust, linear regression model. Get ready to divide and conquer. Section 6. Splitting data for training and testing. Imagine you're learning to ride a bicycle. You wouldn't want to practice only on a smooth, empty road. You need to experience different terrains and obstacles to become a skilled rider. The same principle applies to machine learning. We can't train our model on the entire dataset. We need to hold back a portion to test how well our model generalizes to unseen data. This is where the train-test split comes in. We'll split our data into two parts, a training set, which is 80%, and a testing set, which is 20%. The training set is like our practice ground, where our model learns the relationships. The testing set is like the final exam, where we evaluate its performance on unseen data. In this code, we first separate our features, x, from our target variable, y. Then, we use the function to create our training and testing sets. By splitting our data, we ensure our model doesn't simply memorize the training data. Instead, it learns to generalize and make accurate predictions on new, unseen data. Now that our data is prepped and ready, it's time for the main event. In the next section, we'll learn how to build and train our linear regression model. Get ready to witness the magic of machine learning. Section 7. Building and training the model. The moment we've all been waiting for. It's time to build and train our linear regression model. Thanks to scikit-learn, this process is surprisingly simple. First, we need to create an instance of our linear regression model. Think of this as calling upon the linear regression algorithm from scikit-learn's library. Now we unleash our model on the training data. We use the method to train our model, feeding it the training features, x_train, and their corresponding target values, y_train. During training, our model learns the relationships between the features, like crime rate and number of rooms, and the target variable, housing price. It adjusts its internal parameters like m and c in our equation to find the best fitting line through the data points. Congratulations! You've successfully trained your first linear regression model. Our model has now learned from the training data and is ready to make predictions on new, unseen data. But how do we use our trained model? In the next section, we'll learn how to predict outcomes for new data points and visualize our results. Get ready to see your model in action. Section 8. Predicting and visualizing results. With our trained model in hand, it's time to put it to the test. We can now use it to predict housing prices for new data points. We'll use the method and feed it our testing features, x_test. The model will then churn out its predictions for the corresponding housing prices. Now we have two sets of values, the actual housing prices, y_test, and our model's predictions, y_pred. Let's see how well our model performed. Visualization is key to understanding our model's performance. A scatter plot can help us compare the actual versus predicted values. The closer the points are to a diagonal line, the better our model's predictions. We can also calculate various metrics to quantify our model's accuracy, which we'll explore in the next section. Visualizing our results helps us understand our model's strengths and weaknesses. It allows us to communicate our findings effectively and gain insights from our data. In the next section, we'll dive into evaluating our model's performance using metrics like R² and mean absolute error. Get ready to assess your model's accuracy. Section 9. Evaluating model performance and beyond. We've trained our model and made predictions. But how do we know if it's any good? This is where model evaluation comes in. We use various metrics to assess our model's performance. One commonly used metric is R², also known as R2. It tells us how well our model's predictions fit the actual data, with a value closer to 1 indicating a better fit. Another useful metric is mean absolute error, or MA. It measures the average absolute difference between our model's predictions and the actual values. Lower may means better accuracy. These metrics provide valuable insights into our model's performance. They help us understand how well our model generalizes to unseen data and identify areas for improvement. But our journey doesn't end here. Linear regression is just the tip of the machine learning iceberg. There's a whole world of algorithms and techniques to explore. Remember, the key is to start with a clear understanding of your data and the problem you're trying to solve. Choose the right tools and techniques, experiment, and never stop learning. Congratulations on completing this introductory journey into the world of linear regression with Python. Now go forth and unleash the power of prediction.